Hey everyone, thank you for watching this video. Let's solve another one Leetcode question. So, what does it say? We have provided to non-empty linked list, and each linked list representing a non-negative integer. And what we need to do, we have to find out the sum of two integers and return it as a linked list. So that's the simple problem statement, right? So like all other videos, after getting the problem statement from our interviewer, we need to actually clarify the problem a little bit more to understand the constants of this problem statement, right? So there are some other things mentioned in this problem statement. The first thing is the digits are in reverse order. So I think you have a question in your mind, right? Why they provide the digit in reverse order in linked list? Because if you have fundamental knowledge in arithmetic sum, then you know the arithmetic sum actually. Suppose if you want to sum 1 6 5 or 1 5 0, then it actually start from right to left. We have to move from right to left, right? So 5 11 and 2, so that's the sum. But they actually provide in linked list. So but in linked list actually we always need to browse from head to tail, right? Head to tail, we can't actually browse linked list from tail to head because it's a single linked list, right? So that's actually to make it actually simple for implementation. They actually give the digit in reverse order, and also we have to return the result in reverse order, because the actual example, because this one and this one, actually the actual digit actually 3 4 2 and 4 6 5. So if you sum 708 807, but they return it in 708 in reverse order, right? So that's our problem statement, right? Now our next thing is to we need to discuss with our interviewer to know like more about the problem statement, like what other things you need to consider, right? Okay, so the first things you need to discuss with our interviewer, like what is the maximum length of this uh, linked list, what is the max length, right? Because there is suppose your interview give an example, but you definitely need to discuss what is the maximum length. Suppose your interview says okay, it could be like 1 to 100 each linked list, right? The next things you need to discuss, okay, so are this both of the linked list actually are same size? So this is also very important, because if they are not size same, then you definitely need to handle some corner cases, right? So are those in same size? The interview says okay, no, right? Okay, the next thing you need to discuss, okay, what is the max size of every element it contain, right? Suppose it has actually three different node, and every node actually contain like digit 2 4 and 3. So we need to know like, is there any possibility like this, what is the max length of every digit, right? So suppose your interview says it could be like 0 to 9. So to make it simple, they actually already mentioned in a problem statement as well. There is no like double digit number in linked list node, right? So what is the next thing? So Now there is already some of the information mentioned in this statement, so we are not going to discuss those things or explaining here, because suppose it already mentioned the linked list never be empty. They are actually non-empty linked list will be provided, so we don't need to handle like any empty cases, right? And another one thing mentioned, there is no leading zero of this digit, so there is no possibility like 0 2 4, this type of digit. It is also mentioned in our problem statement, so we don't need to discuss it as well, right? Okay, so these are the like our problem statement, right? Now we need to think like how can we solve this problem. So as I said, we definitely, if we don't have any solution in our mind, we can't start with like brute force solution, right? But for this problem statement, actually this problem take as medium, because uh, it's not a difficult problem. It's, because it take as medium because the implementation actually is difficult, because we need to handle some of the actually corner cases properly. That's actually take as medium size question. And also there is no, we don't need actually any special data structures or algorithms to solve this problem. We just need to know one thing. We have some of the idea like how linked list data structure works. We should have fundamental understanding about like single linked list, right? So this is the one thing we require to solve this problem. Okay, now how do we okay, now just think about it. How do you actually think about it? Suppose if someone provide you this example, right? Okay, so let's start from a blank page linked list, then try out how can we actually like find out the sum of this two linked list, right? So if you have this digit, suppose forget about linked list. If you have this digit, then in arithmetic, how actually you are going to sum of this two digit, right? Suppose you have this digit, right? Suppose 1 2 3 2 1 3. What actually we do in arithmetic? We actually try to sum of the sum of two digit in like suppose 1th position, 10th position, and 100th position. So in one position 3 plus 3 it's a 6, right? Then move here, then 2 1 is a 3, then move here, then 3, right? So that's in linked list also we can do it in same way, right? Because in linked list you can't actually move in random places. You always need to start from head node if you want to browse linked list, right? So that's actually this problem is all about actually implementation. And so suppose we start from like both of the linked list from head node. So this is our head node, right? So we just take a pointer here and another one pointer here, right? Now we just sum of the two of the node values. Suppose it's this one, this two. So 1 plus 2, so it's a 3. So then where actually keep those values? Suppose in output we need another one linked list, because we need to return it as a linked list, our result, right? So suppose this is our output linked list. So 1 plus 2 is a 3, right? Then move the pointer 2 1 is a 3 again, then move the pointer 3 plus 3 6, right? So this is our answer, right? So this is our answer. Now this is very easy input example. Suppose change one digit. Suppose change this digit to 9. Now start over again. Now see, okay, now start from here again. 1 plus 2 is a 3. Move the pointer 9 plus 1 is a 10. So this is one more interesting case. As per our problem statement, as we discussed in earlier, we can't keep double digit value, right? So now we have a double digit value. It's a 10. 9 plus 1 is a 10. So in arithmetic, if we have this situation, what we do? Actually, we actually keep the value 0 and then move 1, and we carry out the second digit, right? So same like that we can do it in linked list also, right? So suppose 9 plus 1, so what we keep here, so 0, and we have one more carry, like we have a carry digit. So that's why actually we need another one variable. Suppose we name it carry. At the very beginning we don't have any carry, so it was 0. Now it's 1, right? Now it's 1. Now move the pointer. 3 plus 3, 6. But you remember there is carry, there is one carry. So we just add off the carry with our result, right? So 6 plus 1, so it's a 7, right? So that's our answer, right? Okay, this is the second use cases. Now let's change another one digit. Change the input example. Suppose this one also 9. Now start over again. So at the very beginning it is 0, right? Okay. Now move the pointer. 2 plus 1, again 3. Okay, fine. Okay. Now 9 plus 1, 10. So for double digit, what we need to do? We just need to 0 and our carry is 1, right? Now there is also one more double digit rule. 9 plus 3 is a 12. 12 plus 1, so it's a 13. But we can't keep 13 in this note. But we don't have any more note left. Then what we need to do? We have to actually handle this case in our code as well, right? Because if there is a carry remain, then we need to create a new node, right? So suppose what we need to do is a 12, right? 12 plus 1 is a 13. So 13 for 3, and we have one carry. So what we need to do, we have to actually create a different node for this. So you see, they actually provided a linked list with size actually 3 node, but the result is actually 4 node. So this is also a case, right? Now one more case. So suppose this is the case. The first linked list actually have 2 node and the second linked list have actually 3 node. Then what can we do, right? So if you compare it in arithmetic, this is also the same, right? Suppose if you have something like that, 1 2 and 2 1 3, what you need to do? It's a 3, right? 3 3, right? So we always imagine there is a value, there is a digit, but what is the value of this digit? It's a 0, right? So in our linked list also we can think something like that, right? Because if we start from here again, so 1 plus 1, 1 plus 2 is a 3, right? Move the pointer. 9 plus 1 is a 10, so 0, we have a carry 1. Now for this linked list there is no node, right? There is no node. So what we need to imagine here? We need to imagine there is a 0 available, and move our pointer, move this pointer here. So 3, there is no node, so we just keep it as a, imagine there is a value, there is a digit which is 0. So 3 plus 0 is a 3, but there is one carry, so 3 plus 1 4. So that's our result, right? So that's the 4 cases we need to handle in our code implementation, right? So let's go for the code. Okay, so what is the time complexity and space complexity of this solution? Just we discussed here. So the time complexity is, here we are actually browsing the tooling list, like in a for loop, right? But the it's a the time complexity is actually the size of n, right? It's linear, but there are actually two linked lists, so it's actually max of m and n. Suppose m is the length of linked list 1 and n is the length of linked list 2. And the space complexity is also same, right? Because we are using some auxiliary extra space to keep our result, right? So this is the space complexity. Okay, let's solve. Let's implement. Write the code for this solution. So suppose the output node. Suppose keep it in output, right? So it's a list node. So just assign it as 0. So and we need one carry variable, right, to keep the carry, right? So this is actually to keep the result, right? Okay, now we have to run a loop, right? We have to run a loop for both to browse actually both of the linked list, right? So that's actually, suppose if we run a while loop L1, if there is any node in L1 or in L2, right? Or we have to use a carry node, because carry also, if there is any carry. Why? Because in our discussion we see that if we have a situation something like that, at the last node, if it is actually double digit, then there is actually a carry digit which actually need to keep in a new node, right? So that's actually we have to keep our loop continue if any of them exist any node, right? Okay, so the next thing is you need to do actually to find out the value, right? So suppose L1 value L1 dot val, because in above implementation you are seeing they actually keep the value in val variable, right? So val if L1 exists, because in our discussion you see that there is a situation where actually L1 node exists in L1, there is no node exists in L2. So in that case, if we don't have any condition check, like any none check, then actually there is a situation we will have exception. So that's why we have to first check L1 dot will access the actually value if L1 not exist. If not, then what we decided, we'll imagine it as 0, right? So that's why we keep it 0. L2 value if L2 exists, else 0, right? Okay, so we find out the L1 value and L2 value. Now we have to actually find out the total, right? So total is L1 value plus L2 value plus what? We need to actually add carry also. So if there is any carry, right? Okay, so now this is our actually sum, right? Like is digit sum, right? with this sum. Okay. Now what you need to do, because there is also two cases. The total could be one digit or double digit. If it is double digit, then we have to find out like what is the value we need to keep in our note and what would be the carry, right? So two things you need to find out. So how can we find out the carry and note value? So first of all, to find out the carry, what we need to do, we need actually total to find out the carry value, right? We need to divide it by 10. Then it will actually give us the carry. And to find out the note value, mm, so find out the note value, we need to it's a, we can say it's a note value, or we can say yeah, we can say it's a note, or we can just say it's a value, and is total modulus by 10, because we need to find out the value. Because suppose if it is if the digit sum suppose 13, if digit sum 13, then this one actually give us 3, because 3 is the value we need to keep in our note, and then it give us 3, right? And if digit is 13, then it give us 1, right? Okay. Now what we need to do, we have to actually keep it in our output value, right? So output dot next equal to list note belt, right? Now we have to move our pointer. The first pointer we need to move the output pointer, right? Output equal to output dot next, right? And L1 equal to L1 dot next if L1 exists, right? If there is no value in L1, there is no note in L1, then we just say it's none, right? And L2 equal to L2 dot next if L2, otherwise we need to return none, right? Okay, so what we need to return the output, right? But we added extra note in our output variable, so we don't need to return it, right? So that's actually we need to return the next note, so that it will. But there is also a problem. You know why? I just keep it in this way, so that I try to make you understand why should we use a different node variable. In that case, we are actually keeping the output variable in this variable, right? But we are also browse the we are also actually moving the pointer in our at the end. So if we return this, then it always actually give us a non value. Why? Because if in our example cases, if the result is suppose 702, if the result actually 702, then actually we are actually moving our output pointer, right? So that's why actually we need another one node. Suppose we say it's the output node, and here we don't need actually we can't move our pointer, because if we move our pointer, then we can't return back to our linked list. right? So right, now it will work, because now actually we are actually using a different node to move our output pointer, but the head node is, the head node are remain in his original pointer. If you like uh, study the linked list properly, then you definitely understand it why actually we are using our extra node variable. So suppose submit it, then see what's the result. Okay, so if we submit it, then you can see, okay, it's accepted, right? Okay, so thank you again. Please subscribe to my channel if you want more videos like this. Thank you.